Unlocking the Cosmos, 50 Years of Human Endeavors in the Search for Extraterrestrial Life. Introduction. The quest for extraterrestrial life has captivated humanity for centuries, but it has gained unprecedented attention and scientific rigor over the past 50 years. The search for extraterrestrial intelligence SETI represents a blend of astronomy, biology, philosophy, and technology, all aimed at answering the age-old question, are we alone in the universe? This report delves into the evolution of SETI, the technological advancements that have propelled the search, and the implications of potentially discovering intelligent life beyond Earth. Historical milestones in SETI. 1. 1960, Project Ozma. Frank Drake, an astronomer, initiated Project Ozma, the first dedicated attempt to detect signals from extraterrestrial civilizations. By focusing on two nearby stars, he sought to pick up any radio emissions that could indicate intelligent life. 2. 1961, the Drake equation. Drake formulated the now famous Drake equation, which estimates the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. This equation considers factors such as the rate of star formation, the number of planets that could support life, and the lifespan of civilizations capable of interstellar communication. 3. 1996, Martian microbes. NASA's announcement of potential fossilized microbial life in a Martian meteorite marked a significant moment in the public's perception of extraterrestrial life. It demonstrated that the universe could harbor life forms, albeit primitive, beyond Earth. 4. 2000s, technological advancements. The development of advanced radio telescopes such as the Allen Telescope Array revolutionized the search for extraterrestrial signals. These instruments can monitor hundreds of millions of channels simultaneously, vastly increasing the chances of detecting a signal. 5. 2016, multidisciplinary approaches. Natalie Cabral's call for a multidisciplinary approach to SETI highlighted the importance of integrating astrobiology, planetary science, and data analysis techniques to broaden the understanding of life in the universe. Technological progress in SETI. The technological landscape of SETI has evolved dramatically. Initially limited to single-frequency searches, modern SETI employs sophisticated algorithms, machine learning, and big data analysis to sift through vast amounts of cosmic noise. This has enabled scientists to detect and analyze potential signals more effectively. Key advancements include radio astronomy. The use of radio waves for communication has been central to SETI. Modern telescopes can detect faint signals from billions of light-years away, enhancing our ability to monitor celestial bodies. Optical SETI. This approach involves searching for laser pulses from extraterrestrial civilizations, providing a complementary method to radio frequency searches. Artificial intelligence. Machine learning algorithms are now employed to identify patterns in data that might indicate extraterrestrial signals, allowing for more efficient analysis of the enormous datasets generated by modern telescopes. Philosophical and ethical implications. The search for extraterrestrial life is not merely a scientific endeavor, it raises profound philosophical and ethical questions. The potential discovery of intelligent life could fundamentally alter humanity's worldview. Key considerations include 1. Societal impact. The discovery of extraterrestrial intelligence could unite humanity in a common cause, fostering collaboration across nations. However, it could also lead to fear and anxiety about potential threats from advanced civilizations. 2. Communication protocols. If a signal is detected, protocols must be established for how to respond. The International Academy of Astronautics has proposed guidelines emphasizing verification and international consensus before any communication occurs. 3. Ethical dilemmas. The ethical implications of contacting extraterrestrial civilizations, especially if they are less technologically advanced, must be carefully considered. There is a risk of inadvertently causing harm or exploitation. Astrobiology and the search for life. Astrobiology plays a critical role in SETI by informing the search parameters based on what we know about life on Earth. Research in this field has expanded the understanding of planetary habitability and the conditions necessary for life to thrive. Key findings include exoplanets. The discovery of thousands of exoplanets, many located in the habitable zones of their stars, has bolstered the belief that potentially habitable worlds are common in the galaxy. Biosignatures. Scientists are developing methods to identify biosignatures, chemical indicators of life, in the atmospheres of exoplanets. This could guide future observations and enhance the search for extraterrestrial life. Life's variability. Understanding the diversity of life on Earth, including extremophiles that thrive in harsh environments, broadens the scope of what constitutes life and informs the search for extraterrestrial organisms that may not resemble Earth-based life forms. Challenges and future directions. Despite the advancements, the search for extraterrestrial life faces several challenges. 1. Technological limitations. While technology has improved, limitations in detection sensitivity and the vast distances involved pose significant hurdles. Future missions may require even more advanced telescopes and methodologies. 2. The Fermi paradox. The apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations poses ongoing questions about the nature of life in the universe. 3. Interdisciplinary collaboration. A truly effective search for extraterrestrial life requires collaboration across scientific disciplines, integrating insights from biology, astronomy, and even social sciences will enhance the understanding of potential life forms and their habitats. Conclusion. The last 50 years of efforts in the search for extraterrestrial life have transformed SETI from a speculative endeavor into a scientifically rigorous field of study. Advances in technology, a deeper understanding of life's potential variability, and interdisciplinary collaboration will continue to shape the future of this quest. As humanity stands on the brink of potentially discovering extraterrestrial intelligence, the implications of such a finding promise to be profound, challenging perceptions of our place in the cosmos and the nature of life itself. The journey to unlock the cosmos is far from over, and with each new discovery, the possibility of not being alone in the universe grows ever closer. In the discourse surrounding the search for extraterrestrial life, several pieces of counterintuitive information emerge that challenge conventional understandings and provoke deeper inquiry into humanity's place in the cosmos. 1. The Drake equation and its limitations. While the Drake equation serves as a foundational tool for estimating the number of communicating civilizations in our galaxy, its variables are based on speculative estimates rather than empirical data. For instance, the assumption that life progresses from simple to complex forms and that intelligence leads to technological advancement is anthropocentric. It overlooks the possibility that intelligent life could evolve in forms vastly different from humans, leading to the conclusion that we might be searching for versions of ourselves rather than recognizing life forms that could be entirely alien in nature. 2. The focus on technologically advanced civilizations. SETI primarily concentrates on detecting technologically advanced civilizations, relying heavily on radio astronomy and optical signals. This approach is inherently limiting. It assumes that advanced civilizations would communicate in ways we can recognize. However, the vast majority of life on Earth is not technologically advanced, and the complexity of life does not necessarily correlate with intelligence or civilization. This raises the question of how much potential life we're missing as we search for signals from civilizations that may not even exist or communicate in ways we can understand. 3. The nature of life in the universe. Many researchers suggest that microbial life is likely to be far more common than complex life. The assumption that life must evolve complexity to be considered significant is misleading. Life can exist in forms that do not resemble our understanding of biology, and the focus on intelligence may divert attention from the search for simpler forms of life that could thrive in environments vastly different from Earth. For a public reaction to discovery, the common expectation is that the discovery of extraterrestrial life would lead to widespread panic or upheaval. However, historical precedents such as the 1996 announcement of fossilized Martian microbes showed a more subdued public reaction. Surveys indicate that many people might respond with excitement rather than fear, suggesting that humanity may be more prepared for this revelation than previously assumed. 5. The role of stochastic events in evolution. The argument that the evolution of intelligent life is a linear and inevitable process is challenged by the understanding that stochastic random events significantly influence evolutionary pathways. The unique history of Earth, shaped by countless unpredictable events, suggests that the emergence of intelligent life elsewhere in the universe is not a guarantee. This realization complicates the search for extraterrestrial intelligence, as it implies that even if life exists on other planets, it may not follow the same trajectory as life on Earth. 6. Communication across vast distances. The assumption that advanced civilizations would communicate in a manner recognizable to us neglects the possibility that their forms of communication could be incomprehensible or entirely different from our sensory capabilities. This highlights the need for a broader perspective on what constitutes a message and how we might interpret it. 7. The Fermi paradox. Despite the vastness of the universe and the estimated number of potentially habitable planets, we have yet to detect any signals from extraterrestrial civilizations. This discrepancy raises profound questions about the nature of intelligent life, its longevity, and the potential for self-destruction. The paradox suggests that advanced civilizations may be exceedingly rare, or that they tend to self-destruct before they can communicate with us. 8. The potential for a galactic civilization. The idea that we could form a galactic civilization is optimistic, but may not consider the vast distances and timescales involved in interstellar communication and travel. The technological and social challenges of bridging these gaps may render the concept of a galactic civilization more speculative than practical. In conclusion, the search for extraterrestrial life not only challenges our scientific understanding but also forces a re-evaluation of deeply held beliefs about life, intelligence, and humanity's place in the universe. As we continue this quest, it is essential to keep an open mind and explore the myriad possibilities that the cosmos may hold. The report on Unlocking the Cosmos, 50 Years of Human Endeavors in the Search for Extraterrestrial Life, contains several significant points that many readers may overlook. These details, while perhaps not as prominently highlighted as the overarching themes, offer critical insights into the complexities and nuances of the search for extraterrestrial life. 1. The evolution of the Drake equation. One often overlooked aspect is the historical context and evolution of the Drake equation. Initially conceived as a probabilistic model to estimate the number of communicative civilizations in the Milky Way, its simplicity belies the complex realities of extraterrestrial life. The equation has been both lauded and criticized. Yet its role in shaping the conversation about extraterrestrial intelligence (ETI) cannot be overstated. Significance. Understanding the limitations and assumptions of the Drake equation is crucial, as it highlights the inherent uncertainties in estimating the existence of extraterrestrial civilizations. It serves as a reminder that while the search is grounded in scientific inquiry, it is also influenced by philosophical considerations reflecting humanity's desire to find a place in the cosmos. 2. Multidisciplinary approaches to SETI. The report emphasizes the need for a multidisciplinary approach to the search for extraterrestrial intelligence, SETI integrating fields like biology, cognitive sciences, and technology. Natalie Cabral's perspective from 2016 underscores the importance of combining various scientific disciplines to enhance the efficacy of SETI. This approach broadens the parameters of what constitutes life and intelligence. Significance. This integration is vital for expanding the search beyond anthropocentric models of life. By considering diverse forms of life and communication, researchers can develop more robust strategies for detecting signals from potential extraterrestrial civilizations. This shift in methodology could lead to breakthroughs that traditional SETI approaches may have missed. 3. Technological advances in signal detection. While the report discusses advancements in detection technologies, the specifics of how machine learning and big data analytics have transformed the SETI landscape are often glossed over. Current technologies can monitor hundreds of millions of channels simultaneously, significantly increasing the chances of capturing extraterrestrial signals. Significance: the application of advanced computational methods not only enhances detection capabilities but also reflects the ongoing evolution of SETI as a scientific discipline. Acknowledging these advancements is essential for understanding the potential future of SETI and the likelihood of finding extraterrestrial life. 4. Philosophical and ethical considerations. The report touches on the philosophical implications of discovering extraterrestrial life but may not delve deeply enough into the ethical dilemmas that could arise from such a discovery. Questions about how humanity would react, the potential for communication, and the implications of encountering a civilization more advanced than our own are profoundly significant. Significance: addressing these ethical considerations is crucial for preparing humanity for the potential realities of contact with extraterrestrial civilizations. It forces society to confront its biases, fears, and hopes about life beyond Earth, fostering a more nuanced understanding of our place in the universe. 5. Public perception and response. Finally, the report discusses how the public might react to the discovery of extraterrestrial life, noting that initial excitement might be tempered by anxiety or disbelief. The historical context, such as the reaction to the 1996 announcement of fossilized Martian microbes, illustrates that the public is capable of handling such news with a level of rationality. Significance: understanding public perception is integral to the discourse surrounding SETI and the broader implications of discovering extraterrestrial life. Preparing for a range of responses from enthusiasm to skepticism can help scientists and policymakers communicate effectively and responsibly about such discoveries. Conclusion. In summary, while the report provides a comprehensive overview of the past 50 years of efforts in the search for extraterrestrial life, it is the nuanced details, such as the evolution of the Drake equation, the need for multidisciplinary approaches, the impact of technology, the philosophical and ethical considerations, and the societal response that hold significant weight. Recognizing these aspects is crucial for advancing the search for extraterrestrial intelligence and preparing humanity for the profound implications of such a discovery. By examining these often overlooked points, we can foster a more informed and thoughtful dialogue about our place in the cosmos and the potential for life beyond Earth. For valuable points for in-depth analysis and discussion on the search for extraterrestrial life. 1. Technological progress and multidisciplinary integration. The evolution of technologies in the search for extraterrestrial intelligence SETI has been remarkable, transitioning from Frank Drake's initial radio experiments in the 1960s to modern-day detection methods involving machine learning and big data analysis. This technological advancement allows researchers to monitor vast swaths of the electromagnetic spectrum, significantly enhancing the potential for detecting extraterrestrial signals. Furthermore, the integration of diverse scientific disciplines such as astrobiology, planetary science, and cognitive science has become crucial for the effectiveness of SETI. This multidisciplinary approach enriches the understanding of various factors influencing the existence of life, including planetary habitability, the nature of biosignatures, and the evolutionary pathways that might lead to intelligent life. Analyzing how technological progress and interdisciplinary collaboration can continue to shape SETI will provide insights into the future of this field. 2. Philosophical and ethical implications. The discovery of extraterrestrial life raises profound philosophical and ethical questions. These include considerations about the societal impacts of such a discovery, the ethical dilemmas involved in potential communication with alien civilizations, and the reactions of diverse global communities. The implications of finding alien life extend beyond scientific curiosity. They challenge deeply held beliefs about humanity's place in the universe. Discussions around the potential responses to a detected signal, including whether to reply and how to frame such a response, are essential. Exploring these philosophical and ethical dimensions will help prepare humanity for the complex moral landscape that may arise from contact with extraterrestrial intelligence. 3. The Drake equation and its limitations. The Drake equation serves as a foundational framework in SETI, providing a probabilistic approach to estimating the number of detectable extraterrestrial civilizations. However, its reliance on many speculative variables, particularly concerning the development of intelligence and technology, highlights its limitations. A critical analysis of the Drake equation can reveal how it reflects an anthropocentric bias focusing primarily on lifeforms that resemble humanity. Additionally, the equation's emphasis on technological civilizations may overlook simpler forms of life that could be abundant throughout the universe. Engaging in a dialogue about the Drake equation can lead to a more nuanced understanding of the types of life that may exist beyond Earth and how we might adjust our search strategies accordingly. 4. Public perception and response to discovery. The public's reaction to the potential discovery of extraterrestrial life is a significant aspect of the SETI discourse. Historical instances such as the announcement of fossilized Martian microbes suggest that the public may be more capable of processing such news than previously assumed. Surveys indicated general excitement and hopefulness towards the idea of extraterrestrial life rather than fear or panic. However, the implications of confirming extraterrestrial intelligence are multifaceted. Discussions around how such a discovery could unify or further divide humanity. The role of media in shaping public perception and the potential for a new interpretation industry to emerge are critical. Understanding these dynamics will be essential for SETI researchers and policymakers as they navigate the societal implications of their findings. These 4 points, technological progress and multidisciplinary integration, philosophical and ethical implications, the limitations of the Drake equation and public perception, represent crucial areas for in-depth analysis and discussion in the ongoing quest to unlock the cosmos and understand our place within it. 1. The Drake equation, 1961. In 1961, astronomer Frank Drake formulated the Drake equation during a meeting at the Green Bank Observatory. This equation was intended to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. The equation considers multiple factors, including the rate of star formation, the fraction of those stars that have planets, and the number of planets that could potentially support life. The Drake equation catalyzed scientific discussions about the search for extraterrestrial intelligence SETI and established a framework for future research in astrobiology. 2. Project Ozma, 1960. Project Ozma, initiated by Frank Drake at the Green Bank Observatory, marked the first modern scientific effort to search for extraterrestrial signals. The project involved listening for radio signals from 2 nearby stars, Epsilon Eridani and Tau Ceti. Although no signals were detected, the project laid the groundwork for future SETI initiatives and highlighted the potential for communication with intelligent extraterrestrial life. 3. The WOW! Signal, 1977. On August 15, 1977, astronomer Jerry R. Emmon detected a strong narrowband radio signal while working on a SETI project at Ohio State University's Big Ear Radio Telescope. The signal, dubbed the WOW! Signal, lasted for 72 seconds and was unlike any known natural or artificial source. The intensity of the signal and its specific frequency led to speculation about a potential extraterrestrial origin. Despite numerous attempts to detect the signal again, it has never been observed again, making it a tantalizing unresolved mystery in the search for extraterrestrial life. These historical cases serve as significant milestones in humanity's ongoing quest to understand our place in the cosmos and the possibility of life beyond Earth. Future outlook, predictions for the search for extraterrestrial life. The search for extraterrestrial life has captivated humanity's imagination for decades, evolving from speculative musings into a scientifically rigorous endeavor. As we look ahead to the next 50 years, several predictions can be made regarding the future of this field, shaped by technological advancements, scientific collaborations, and philosophical considerations. 1. Technological advancements. The next few decades will see unprecedented advancements in technology that will enhance our ability to detect extraterrestrial signals. The development of more sensitive and powerful telescopes such as the next-generation James Webb Space Telescope and large arrays like the Square Kilometre Array will allow us to scan vast regions of the sky with greater precision. Machine learning algorithms will play a crucial role in analyzing the immense data generated by these instruments, enabling researchers to identify potential signals of extraterrestrial origin more efficiently. 2. Interdisciplinary collaboration. The future of the search for extraterrestrial life will increasingly rely on interdisciplinary approaches. Collaboration among astrobiologists, astronomers, chemists, and social scientists will be essential to address the complexities of this search. For example, understanding the biochemical signatures of life may require insights from both biology and planetary science. While the implications of a discovery will necessitate input from ethicists and sociologists to prepare society for potential contact. 3. Increased focus on exoplanets. The discovery of thousands of exoplanets in recent years has shifted the focus of extraterrestrial life searches toward these distant worlds. Future missions will prioritize the study of Earth-like exoplanets located within their stars' habitable zones where conditions may be suitable for life. Advanced spectroscopic techniques will be employed to analyze the atmospheres of these planets for biosignatures, chemical indicators that suggest the presence of life. 4. Addressing the Fermi paradox. The Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations, will continue to be a central question in the field. Researchers will explore various hypotheses, including the possibility of advanced civilizations being rare, the limits of our detection methods, or the idea that intelligent life may be deliberately avoiding contact. This philosophical inquiry will motivate research into the nature of intelligence and the conditions under which it can arise. 5. Public engagement and ethical considerations. As our search for extraterrestrial life progresses, public interest will grow, leading to increased engagement and discourse about potential discoveries. Educational initiatives and outreach programs will help demystify the scientific process and foster a more informed public dialogue about the implications of finding extraterrestrial life. Additionally, ethical considerations surrounding contact with alien civilizations will become paramount. Discussions about how to communicate or respond to extraterrestrial signals will involve global cooperation and consensus building to navigate potential risks. 6. The search for technosignatures. Future SETI efforts will expand beyond traditional radio signals to include the search for technosignatures, artifacts or emissions produced by advanced civilizations. This could range from laser signals to megastructures around stars like Dyson spheres. Enhanced observational capabilities will allow scientists to detect and analyze these potential indicators of intelligent life. 7. Exploration of our solar system. Missions to explore the moons of Jupiter and Saturn, such as Europa and Enceladus, will be prioritized, given their subsurface oceans and potential for harboring microbial life. The results of these missions could provide crucial insights into the conditions required for life and inform our understanding of life's prevalence in the universe. 8. Philosophical and sociological implications. The discovery of extraterrestrial life will challenge our understanding of humanity's place in the cosmos. Philosophical discussions around the nature of intelligence, consciousness, and the potential for cooperation or conflict with alien civilizations will emerge. Sociologists will explore the impact of such discoveries on human society, culture, and belief systems, addressing questions about identity, spirituality, and our collective future. 9. A unified framework for SETI. As the scientific community embraces a more integrated approach, the creation of a unified framework for SETI will be necessary. This would involve the synthesis of data from various disciplines, including astrobiology, cognitive science, and environmental science. to create a comprehensive understanding of life beyond Earth. A holistic roadmap will guide future research, ensuring that efforts are focused and aligned with the overarching goal of understanding extraterrestrial life. 10. Long-term vision. By 2075, we may reach a point where our understanding of extraterrestrial life is significantly advanced, potentially leading to the detection of biosignatures or technosignatures. This could trigger a paradigm shift in human thought, prompting a reassessment of our societal values, technological priorities, and philosophical beliefs about existence and consciousness. In conclusion, the future of the search for extraterrestrial life is bright and holds immense potential for scientific discovery and philosophical exploration. As we advance technologically and deepen our understanding of the cosmos, the quest to unlock the mysteries of life beyond Earth will remain a central endeavor for humanity, shaping our destiny and understanding of our place in the universe.